Hello and welcome to Talking Points. I'm Dave Kelly, Director of Advanced Media Production at Cal State Long Beach. Today we'll be talking about Geographic Information Systems and Geographic Information Science, both commonly known as GIS. My guest today is Dr. Paul Laris. Dr. Laris is a professor and he is also the chair of the Geography Department. Welcome, Paul, and thank you for joining us on Talking Points.
Thanks for having me.
To start this conversation, I think we can acknowledge that most people have a pretty good understanding of what's referred to as GPS, which is the Global Positioning System, which helps us navigate in our automobiles and also with our smartphones. So tell us, how is GPS related to GIS? And then give us a broader description of GIS to tell us exactly everything it entails.
Okay. I think of a GPS, actually the GPS is a global positioning system which helps put your location on Earth into a coordinate system, so giving it geographic coordinates. And that can help you navigate to a particular location that also has on a map or has geographic coordinates to it. A GIS, or a Geographic Information System, is a much more elaborate system. Parts of GIS include, you can think of it as a black box. We're going to store data in this box. We're going to integrate different layers of data, information about weather, information about roads, information about environmental features, urban features. A GIS can also do analysis. And perhaps even most importantly, one of the things that a GIS has to do is to show you or visualize that information in a way that's useful to help you make decisions. So that's what a GIS system is. You can think of a GPS unit in your car as a little miniature GIS. It's more than just a device to find your location on Earth. When you use your GPS in your car, you have a data set, you have information stored in that system or connected to the storage. You also have the ability to do some very simple analysis, find all the Pete's Coffee that's located within 2 miles of where I am. And of course the GPS is very good at helping you make that decision by giving you a visual representation of where you are on a map vis-a-vis some location that you're trying to find.
So how did we evolve from GIS from the Geographic Information Systems into Geographic Information Science?
Well, I think the science indicates the evolution of the field, the maturation of the field. If you think of computer systems, we all know how to use a desktop computer or a laptop computer, but we're not experts, we're not scientists. And so computer science represents the academic kind of evolution of that field. The same thing with a GIS. As GIS has evolved, it's become much more complicated, and I think you could think of it as a user using a GIS system. Like myself, I use GIS to answer questions about the environment and people. But then there are those scientists who are creating the new applications, the new uses of GIS. And I don't consider myself a GIS scientist by any stretch of the imagination.
And as far as GIS is concerned, it's very widespread today. How did it actually begin, and why is it so widespread today?
Well, I think that, I was watching the Steve Jobs, the Jobs movie on the plane coming back from Africa recently, and the evolution of the desktop computer or the portable computer was fairly sexy in that story. I think GIS evolved in a much more kind of gradual, almost I can't think of the word, generic kind of way, where you had a bunch of different user groups. You had geographers, you had cartographers who make maps, you had people using aerial photographs, you had computer scientists, and they were all trying to automate, cartography or map making, and gradually working towards creating those different parts that go into a GIS. And I think on the academic side, you had that going on. On the public use side, if you think of a city, and all of the information that a city has, where are the cable lines running underneath your streets? Where are the gas lines running underneath your streets? Where's the best route for your fire trucks to go? They have all this information that they have to manage, and it's all geographic information. It's all tied to a coordinate system. And so cities really needed a GIS system, and so that also helped to push for the development of those systems. Why did it develop so fast and it become so widespread? I think GIS is seductive. You could push a couple of buttons and see something new and different by combining a bunch of different information that you couldn't do before. And so I think anyone who's played with Google Earth or taken a look at a GIS system can kind of sense that seductiveness, and that's why you'll become interested in it.
And I think that most of us had our first exposure to GIS through the use of satellite photos and the recognition of satellite photos and what they can do with Google Earth and things of that nature. But we don't just have to use satellites now. We have some aerial vehicles, unoccupied aerial vehicles, that can also do the same sort of thing. And you've prepared a very elaborate show and tell for us today. So we're going to begin with our first video clip of an aerial vehicle, unoccupied aerial vehicle, flying over the campus. Let's roll that clip now.
So what you see here is a shadow of a quadcopter, and there it is taking off. There's a student who's piloting it, and it's going to fly over the campus, and it's just going to give you an idea of the kinds of images you can get from a UAV. This particular one is being navigated by the student pilot, but others can be programmed to fly a very specific pattern to capture data in very hard to get to places, for example. And here you see the UAV, the quadcopter, coming down for a nice, safe touchdown there on the athletic fields at the CSULB campus.
And how would this sort of technology be helpful for academic studies?
Well, for example, when I first started doing my own research, to get a satellite image of a particular area on Earth would cost you several $100s. And now you can get some of those images for free, but if you want a really high definition or a high resolution image of a particular area, it's going to cost you thousands of dollars to have a satellite go and snap that image. Alternatively, with the development of these UAV systems, you can now buy yourself a small quadcopter. You can hook it up with a GoPro camera or a camera that has different lenses for detecting infrared radiation, for example. And you can set that up to fly a particular flight path and capture information on Earth that would have been very expensive to do using a satellite image. And you can do it in a quick way. You can get to hard to get to places. Mm-hmm. And that's the advantage, I think, of the UAV system.
So it's added a lot of convenience to the process.
I think it's added a lot of convenience to it. It's cut down on cost. But there's also things, we don't even know the kinds of information that we're going to be able to find. For example, in Hawaii, there's, people are very worried about invasive species, right? Hawaii is an island. It has this amazing biodiversity of plants, and yet an invasive species can get in there and just explode and take over the landscape. So I call these species, invasive species, plants behaving badly. However, the key to stopping invasive species is to find out where they are early on in the process. And flying over with a UAV will allow you to capture imagery and then put that imagery in a GIS where you can analyze it and say, pick out the examples of those invasive species whenever you see them, and then have someone go out there and eradicate them. That's just one example.
Let's talk about your specific work on the fires in Mali in Western Africa. So we've got some slides that we can show. Let's take a look at our first slide. What are we looking at here?
So we're looking at an image here that's generated from satellite. You have Africa in the background and a little bit of South America there on the left. And all of the red in the image are pixels that have been burned by a fire. So the land that's turned red in the pixel represents a fire. And these fires, as you can see, spread throughout a large area of Africa and predominantly in the savannas, which are a region of the world that burns more than any other.
Let's take a look at the next slide. And this is your study area.
Yeah, this is my study area in Mali, in the southwest corner of Mali, located in West Africa, which is a savanna region of the world.
And let's take a look at that.
And this is what a savanna landscape looks like. It's a mixture of grasses and trees by definition. The grasses, as you can see in this image, are dry. They tend to be anywhere from 2 to 3 feet tall, all the way up to 2 meters tall. Scattered throughout are different trees, small and large. One of the defining characteristics of the savanna as well is a prolonged dry season. So every year as the rains stop and the landscape dries, fires spread, burning those grasses and some of those smaller trees.
Let's take a look at the next slide. And here's a gentleman setting a fire. Who is he and why is he setting a fire?
Yeah, so this is a Malian hunter, a member of the Hunting Society. And the hunters in Mali have a role of being the environment managers. So they're out traveling in the savanna, in the bush, and this particular hunter has come across a patch of grass that's dry, and it's just dry enough to burn. And so that's appropriate time to set a fire so that it doesn't burn in a very damaging way. And so here he's setting that grass on fire.
Let's take a look at the next slide.
And here you see another hunter who's monitoring a fire that's now well underway. You can see that these grasses are fairly short, and they're going to burn off pretty quickly, especially if the wind picks up and spreads this fire.
Let's go to the next one.
And here is an image from a fire in the evening. A lot of these fires were mapped using satellite images from above, and some of the people doing that analysis initially thought that fires burning in the evening must be uncontrolled fires. However, if you think of someone who's using a fire to manage a landscape, setting a fire in the evening is actually a very appropriate time, because as the sun sets, the temperatures goes down, the humidity will go up, and the fire will literally burn itself out. And that's exactly what people in Africa want to see: a fire burn a particular area, remove a hazard, and then die out.
Let's go to the next slide. What do we see here? The after effect?
Yeah, here's the after effect after a typical grass fire in the savanna, and you can see that the landscape has been denuded of those dry grasses. And in many cases, those dry grasses are not the ones that are of use to people. They harbor pests and ticks if you're running a cattle through the environment. In the background, however, you see some green vegetation. You see the shrubs. You see where the fire literally died itself out. Perhaps in the evening when the humidity rose, it died at the edge of this area. And this is an example of how people use fire to modify the landscape.
Let's go to the next one.
And here's another example of a modified landscape. One of the goals of burning is to fragment the landscape so that a big sweeping fire can't come through. And here you see in the foreground an area that had burned early, and in the background an area that had burned somewhat later, and some areas that haven't burned at all.
And you referred to this image as a mosaic.
Yeah, this is a patch mosaic landscape that's produced by a strategic use of fire in savannah.
And Paul, you also brought a video clip of the fires where you were actually on the ground with the video. We'll take a look at that in the next segment because we need to take a break right now. But we will be back in just a moment, and join us again for the second segment, and we will show Paul's on-the-ground video. Stay with us.
Hi, I'm Anthony Tang. This summer, I'm teaching Accounting 201, Financial Accounting. Why should you take accounting? We're talking about money, how to use money, as well as how to read financial information in your day-to-day lives. So, I'd love to see you this summer online on Accounting 201 Financial Accounting.
Welcome back to Talking Points. I'm Dave Kelly. My guest today is Dr. Paul Laris. Dr. Laris is a professor and the department chair of the Geography department. Paul, we were talking about your research in the fires in Mali before we went to the break. You were on the ground with a video camera, and we have a clip that we're going to show right now with you talking over the video clip. So let's take a look at that clip right now.
One of the things, of course, that fire does in the savanna is it burns small trees. And you can see right now the fire is actually burning up many of these small fallow trees. And these trees doesn't necessarily kill the trees. It can kill the smallest of the trees. Wow, look at that. But the trees that are fairly well established won't die. Look at this one's just burning the leaves and everything off of those trees. It's now well over my head. The flaming front is about 12 to 15 feet high, and that's reaching up into the canopy of some pretty tall trees. I'm going to try and get across to the other side here. See if I can find a little place to cross over without getting my pants burned off. Kind of an interesting idea. Wow, Wow, we just jumped to the other side of the fire. And so as you can see, actually, as the fire comes through here, it's in fact slowly burning itself out. And that's really the intention here. Much of the burning is done as a preventative practice to prevent very hot fires from damaging the trees, to allow the grasses to resprout new green leaves, which provides fodder for cattle and animals. And as you can see, if you look around on the ground here, even though things look fairly charred from a distance, as you get closer, you see that there's many little sprouts of grasses and other plants.
Okay, Paul, you've been involved in this research now for over 10 years. And what are you learning from this research, and why would you spend 10 years on it?
Well, I think the reason I'm spending so much time on fire has to do with all of the things that you saw in that video clip. Fire burns trees, it causes deforestation, and it transforms the vegetation cover on large areas of the planet. Fire releases a lot of smoke. And within that smoke, there are gases, and our latest research project is to understand what kinds of gases are being released from these fires, how much of them, and how do they affect the atmosphere in terms of what they might have implications for climate change. And the final thing is that local people have a very interesting way of practicing a fire management, and perhaps we can learn a lot from how they use fire, and maybe GIS and satellite imagery can help them better manage the fire in their landscape.
And I would think that you would want to study it for a longer period than just a year or two, because you need to see what the patterns are and if the patterns have some consistency over a decade or so.
That's exactly right, and that's why the GIS is so useful. I can take a whole bunch of satellite images, and I have them for about 30 years, put them in a GIS, analyze them for the fire patterns, and then look at statistics about how frequently certain areas burn and what kinds of patterns there are. And that's very useful information that we want to take back to Africa, actually, to spread an exchange with our collaborators there.
Are there some other uses of GIS for environmental disasters, for example, a tidal wave or a tsunami or something that occurs, an earthquake? Have you seen other uses for this kind of thing?
Well, yeah, there's been use of GIS in hazards management or emergency management. And in fact, the UAVs that we saw earlier are one device that's being used. So for example, if you have a hard to get to place and an emergency there, imagine Katrina during the floods, UAVs can go out and collect useful information that can then be put back in a GIS for analysis and to help emergency people get back in the field.
Let's talk about some other uses of GIS. It's not all about the environment necessarily, although that's one of the larger uses of it. But we also can use it for things like sports research, and you have a clip for us there. Let's take a look at that clip.
Okay, what you see here is a play by two professional basketball teams, and you see each individual dot moving, and that represents a player on the basketball court. And when the play is over, we see the lines that trace the pathways of each of these individual players. And it looks somewhat chaotic when you see it in this form.
And we also have a slide that shows us more information. There's the slide.
Right, so here's some work on relative motion analysis of basketball players. On the left, you see that play. And on the right, what you see are three charts that show the individual direction, speed, and acceleration of all of those basketball players. So each color represents a different direction or a different speed, and this is one way of visualizing or representing this information to a user group.
And we have some other applications too where GIS is very helpful, and one of those uses involves interactive maps where people can actually find things, find locations, and if they're traveling on the campus, we can help them find a facility, for example. Let's take a look at this clip.
All right, this is an example of an interactive map or an application for the CSULB campus. This could be on your tablet or on your smartphone or on your laptop. Here we're going to the website with the map of the campus, and you can see, clicking on the right, different aspects. We're looking at vending machines, trash cans, parking lot, visitor information centers, for example. You can do a simple query where you say, hey, for example, I want to find the Anatol Center, or I want to find the library. Type in library, it'll take you to that location. It'll highlight it, and then it'll show you an image of what that location looks like so that you can find it. It could also do things like help you find the best pathway to get to the campus, help you find a bicycle pathway to the campus. It's very useful for visitors, but This kind of what we call enterprise GIS, which is a GIS for a particular organization, such as a campus, is useful also for facilities management who need to know where all of their different equipment is on campus.
And also, if there's an emergency application, this could be useful. For example, a 911 call goes into emergency services. How would they use this information?
Well, the emergency response teams would have these maps. They would know where students are located, where the large classrooms are, for example, where the best escape routes are, where people are likely to congregate after an earthquake, for example, what areas might be prone to flooding, and so they can plan accordingly. In hazards management, people are using lots of GIS in a lot of their work today.
And as we talked earlier about GPS and smartphones and the application of GIS, smartphones are very powerful today and can do a lot of different things with this kind of information. Give me some examples of that.
Smartphones, well, in addition to having a GPS in your pocket that can tell you exactly where you are, for example, you could put this enterprise GIS for the campus on your smartphone. It can help you navigate. So let's say you wanted to find a parking space if you're running late for a class. This is the kind of application of the future that might make getting to and from campus easier for people.
Right, and so that we know that, again, we use it a lot for geography. We use it for finding restaurants. I think you mentioned that earlier. And we also are now able to combine art with science now in these GIS applications. And we have another clip based on that. I told you we'd have a lot of show and tell, and we certainly do today. So let's take a look at this clip, merging art and science within a smartphone environment. Let's roll the clip.
So here what you see is an application. It's a mocked-up application of Calliope on a smartphone, and the line is showing you the path of a traveler, and the dots, each dot represents a different language spoken by presumably a different population from the census. And as you can see, as we're traveling now along our what looks like a GPS through an urban area, we can also see different aspects, different GIS layers. Here we're seeing elevation, and here we're seeing urban landscape versus more rural landscape.
Here we're now color bars.
Yeah, these are examples of the languages spoken by these different populations. And what you're hearing in the background is the music is changing. The beat changes as we go through an area that speaks a different language, perhaps a different ethnic group. As you hear the pitch change, we're going up a hill or down a hill, etc.
And other statistics can also come into play. There was also a red line there that indicated crime stats. Now, how would that be helpful?
Well, again, this is the GIS of the future. The actual applications of this are to be discovered. But for example, if you're driving along and you hear the tone of your music changing, that indicates you're entering a high crime area or a low crime area. Or you're entering an area that has a certain ethnic group. Maybe it's a good time to go out and find that ethnic food that you're looking for, but you'll hear this in terms of the tone of the music rather than some advertisement popping up on your screen.
So this really represents kind of a fourth dimension where we're taking art and science and merging them together to use visual cues, audio cues, information and data all put together in a way that's new and interesting for the traveler. Tell us more about that.
Well, I'm a big cyclist, and I used to do a lot of bike riding in the hills around UCLA when I was a student there. And climbing uphill, I always wanted to listen to a certain kind of music. It got me going on pace. Downhill, I wanted another kind of music. That's the basic idea of this device. But imagine if you're a blind person and walking around and you can hear different music that could help you navigate through areas of a city, for example. The applications are just,
endless.
Endless, exactly. Thank you.
Okay, let's talk about new frontiers. This seems to be a fairly new frontier. Are there some other new frontiers that we can look forward to?
Yeah, one of the other new frontiers with GIS and geographic data is called volunteered data. And what volunteered data essentially means is that the public puts it out there for us to use. And everybody that ever used Facebook or some of these other social media devices has posted a photograph that's geocoded, meaning that it has its spatial location on it, right, is giving volunteer data. And this data could have some uses that we haven't even thought about. So for example, when our house burned up in Santa Barbara a few years back, I went online and found some volunteer data showing a neighborhood that had burned. And there was a picture of a house burning next door to mine. So it told me with pretty good likelihood that perhaps our house had burned. Sometimes that volunteer data has information in it that's gathered before the emergency responders can actually get there. But how do you determine the good data from the bad data? That's the big challenge.
Mm-hmm. So the programmers of the future are going to have to figure out how to synthesize everything and provide it in more or less real time, but very accurately as well.
Right, and this is the thing that a GIS can do. You can look for patterns and recognize the patterns that are more likely to be true than others. I heard a very interesting potential future application of this kind of data. There was a social scientist on the radio talking about happiness. And we know these studies about which countries are more happy than the others. But he wanted to do it in real time, call people up or send them a smartphone thing that they have to respond to. But we could also link that to a location. Are some locations on the Earth ones that make people happier or not? I don't know, this could be something that we study in the future.
We just have about 30 seconds left. Paul, your students, what kinds of careers are they getting into in 30 seconds or less?
Well, GIS is everywhere, as we say. People are working for county governments. They're managing their GIS systems. They're doing urban planning. They're working for businesses. How do you find the best new location for a particular store that you want to open? They're working for emergency responses. They're working for fire departments, for hospitals. And we have some students now working with UAVs going out there, and who knows, they may be helping you deliver something to your home in the future.
Well, that sounds exciting. Thank you so much for being with us today, Paul. And thank you for joining us on Talking Points. I hope you enjoyed this episode. Join us again for another episode in the near future. Until then, I'm Dave Kelly. Have a nice day.